Hello, everyone. It is Monday, August 28th. It is 6:06 p.m. Central Time. We're going to kick off session 7 with going over the solution for detention, which was the last thing we did on Thursday. So we're going to go over some solutions here for this, and then we're going to jump into the slides for session 7. And then we'll go back into challenges. I believe the slides for tonight, we're going to be dealing with truthy and falsy, and then also, which we've kind of discussed earlier, and then we're also going to discuss recursion tonight. Recursion tends to melt brains. Don't worry about it. You don't need to, we will touch on recursion in this class. There's a couple of recursion challenges on our slides. We'll hit a few of those. If you go to a code platoon or any other coding camp, you're going to brush up on recursion again. But it isn't, I mean, I won't say like you won't run into it in an interview or you won't use it in your job, but typically if you're working in JavaScript, like if you can come up with a recursive solution, there's typically a functional solution that is a little bit more performant. And we'll go over why. Some languages are more heavily dependent upon recursion, something along the lines like Clojure, like a purely functional language. I believe Elixir as well. But that's not anything we need to worry about to make it into a coding camp. All right, so let's go ahead and take a look at the solution for detention. So I'm just going to read over the instructions and the prep again here real quick. So all the students in the 5th and 6th grade have detention. You can tell a student is in the 6th grade if 6 is the highest number in their student ID. If the highest number in their student ID is less than 6, they are younger, and if it's greater than 6, they are older. The same rule applies for 5th grade students. Write a method that takes in a student's ID as a string of unknown length and returns a Boolean true. If that student has detention, or false if they do not, returns true if that student has detention, or false if they do not have detention. All right, so parameters, we're going to get a string, which is the student ID, right? And then we need to return a Boolean, true or false, if the student has detention. We've got a couple of examples below here. And then, so we'll look at some pseudocode. And so let's go ahead and break this down here real quick. So we look at this one and we expect it to be true, right? Because we've got a 1, a 3, and a 6. So the highest number in here is a 6. So they would be a 6th grader and they would have detention. Now we look at this one and we see a 1, a 3, and a 6, but just because they have a 6 in there or a 5 in there doesn't make it automatic if they have a higher number, which they do. So they have 7. So this student would actually be in the 7th grade and they do not have detention. So this makes it a little bit trickier than just saying like, does this string include a 5 or does the string include a 6? Because it can include those numbers, but it can also include higher numbers that would prevent the student from having detention. On Thursday or over the weekend, has anyone solved this completely yet? You guys?
Yeah, I did it with just pulling out all the numbers and getting the numbers into its own string and then working from there if finding the max number from there.
Okay, cool. So that's definitely a way to do it. So let's go ahead and see what we can do to solve this here. All right, so again, we're going to take this one step at a time. So if we take a look at our ID, just to make sure we're getting what we expect, right? I'm not worried about the false right now. I've got my full string there. And now what I could do here is we could take a look at a couple of different things to basically loop through here, either loop through the string or break this into an array. And so if I were to take a look at this, maybe my next step would be to write a for loop. And we could say for let I equals 0, I less than ID dot length, and we could say I plus plus. All right, and so let's go ahead and move this inside of our loop, and let's see what we get here. Right, and so ID is a string. Strings have index values just like an array does. Our string is immutable, but I don't really need to change anything in here. So maybe I think my first pass on this will try and solve it without having to break it into an array. Right, so that looks like I'm getting each character in here. Right, and so what we could do is take something like this, and maybe we could go like this and see what happens. So we'll say parse int, right? And so now anything that isn't the string representation of a number is going to get converted to not a number. And so the 1, the 3, the 6 are going to get isolated, and they're going to be converted into a number. Right, and so we could do something like this where we could say let max number equal 0. And so to this point we're here, right, and we could take this out of the console.log, or sorry, I've got a cat screaming in the background. We could say greater than max number, right? And what I would hope to see here, like in this first one, is true, false, false, true, false, false, so on all the way down. And let's go ahead and take a look at this. When we do some comparison, oh, we get false all the way down. Let's see here. So we've got parseInt ID. Sorry, I'm saying triple equals. I want to say greater than max number. Sorry about that. There we go. So there's our truths, right? So now we've done this. So probably what I would do here is get rid of my console.log, and I could say if parseInt is greater than max number, you could say max number is now equal to this. All right. And now let's go ahead. We'll go through our loop. And so that's our if statement, that's our loop. And we could console.log max number. Oops, max number. Right. And I've got a 6 and a 7, which are the highest numbers that I have out of here. Right. And so we could then do something like this. So take it out of the console.log again, and we could say return. Actually, we won't do that. We'll say right, and then we could do something down here where we say return in 5th or 6th, and then we could say if in next number is triple equal to 5, or max number is triple equal to 6. Let's take this out of here. Turn true, else turn false. Let's get rid of this for right now. Clean this up. Space in here. Right, so we get true, true. So which is, this is, if I get rid of this, right, it should be returning false. And it is, because the 7 is the highest number, so we're returning false out of there. And I think I can do a or inside of my ternary. So we can maybe clean this up, right? And then we could just say true, false, that. Let's see if we still get true, true here. Okay. So this to me would be a good way. Halsey, pulling out, like, however we are isolating these, like just the numbers out of here is what we need to do. So we can take steps to pull out the numbers separately. By using the parsint, we're isolating them by virtue of the fact that anything that's not a number is being converted into not a number, literally the type. Any questions on how I solved this one?
Yeah, can you explain what um in line 18 what's going on? Max number equals parsint ID I.
Yes. So what I'm saying on line 17 is that if the number, so remember, so ID is our string, I, because we're going through our for loop, I is equal to 0, 1, 2, 3, so on and so forth. So I'm accessing the index value of my string, and I'm then basically trying to parse it into an integer. And so if it is the string representation of the number one, it would parse into the integer number one. And if it is not a number, so like the letter G or the letter H, it will parse into the type not a number, NaN, and which will basically, this will automatically be false at this point. Like nan will never be greater than any number. And so then we're only getting our numbers here. So 1, 3, and 6. And we're checking to see if the number in my string is greater than the max number, which I've defaulted to 0. And so the first time through, right, like we would get 1. And so we're going to say, is the number 1 greater than 0? That is true. Okay. The max number is now equal to the parsed integer of IDI. So this now becomes 1. Right. And
Okay.
then we'll keep looping through and we'll get to 3, and it'll say is now this time through, it'll say is 3 greater than 1. That is true. So this becomes 3. That's what this is doing down here. It's reassigning the value and to 6.
Okay.
And so if we were to put a 2 in here, right, like it would go from max number would go from 0 to 1 to 3. 2 would be a number, but it wouldn't be greater than 3. So it stays 3, loops through until it gets to 6. Then max number becomes 6. And we exit the loop because it's the last character in our string. And then we check to see if max number is equal to 5 or if it's equal to 6. And then return true or false if it hits either one of these statements.
Okay. Got it. All right. Thank you.
Yep. And also, let me show you this as well. Has anyone come across the site Python Tutor yet? So it does more than just Python. It also does JavaScript. I've never used it for C or Java or anything like that, but I do use it for JavaScript. And what this is a visual debugger that will show you what's happening inside your function step by step. All right, so if we grab this, we'll just copy our code and come over and plunk it down here. And we're going to set it to JavaScript ES6. That's fine. And then we're going to visualize the execution of this. All right. And so what it's telling me is this is doing all of the computations that the computer is doing, but it will show you step by step what is happening. All right. So at the end of step 1, we have taken have detention in loaded this function into memory as a function, right? Like nothing's happened yet. And our cursor is on line 11, ready to take the next step. When we hit the next step, we're actually going to call our function, right? And give it the string, right? So now we have an ID, right? Because our function takes a parameter ID. We've assigned it to this. We know that there is a variable in here in the local scope called max number. Remember, this is a two-step process. The first step is declaring it. The second step is assigning it. So I take another step. Max number is equal to 0. So now we've hit our for loop, right? And so let's go ahead and declare our for loop, right? I is equal to 0, right? We come in here, we have an if statement. So basically we move inside of our if statement and we assign max number the value of 1, right? On our very first pass through, right? We keep going, right? So we're going to hit the letter G. That's not a number. So we basically skip over our if statement because this is false. So we don't execute this code. We go back up into our for loop, right? And we're going through this block by block. And until we hit the block 4. So this should push us up to number 3, right? So max number is now 3. We're iterating through. So nothing's happening because we keep getting not a number. Right, so block 8. So 1, 2, 3. I think this one will be it. No, next one. So this one. All right, we hit that if statement. It's in here somewhere. So there we go. So now we've entered the if statement again. We're going to assign it the value of 6. We're done with our for loop at this point. Max number is equal to 6. We're going to come here and we're going to check it against this, right? And our return value is true. Okay, and so this is pythontutor.com, and this will take the different functions and break them out step by step for you to visually show you what's happening each step of the way. This can be really useful when you're looping through things and you're not getting what you expect out of your loop, right? Like, and it'll show you step by step and it'll help you identify where you possibly went wrong. And then the last step is console.logging it and sending it to the console. All right. Now, and print output true. All right. So any other questions about this or what I did over here, what Python Tutor was displaying? All right. So let's go ahead and move into the slides for session 7 tonight. All right. And we're going to cover truthy and falsy. We've already talked about this in class some. And basically, each value has an inherent Boolean value, generally known as either truthy or falsy. There's 6 things that are false in JavaScript inherently, which is false, the number 0, an empty string, null, undefined, and not a number. Everything else is truthy. All right. And we'll do some demonstrations of that. And that includes 0 as a string, false as a string, because that's just the word false. It has no special meaning to it. An empty array or an empty object or an empty function are all truthy. All right, so let's go ahead and take a look here. So we could do something along the lines of this. So we could say if X, or we'll just call it thing to test. All right. Spelling falsely, right? Okay. Yep, no in there. And so we'll say let thing to test equal an empty string, right? And if we run this, we get this as false, right? So we don't have to have a comparison in here. Like we don't have to have something like this to have it resolved to true or false. Anything that you put inside of an if statement will resolve to either truthy or falsy if you don't give it some sort of comparison operation. All right. And we don't have to do it as a variable, right? Like I could just put the number 0 here. Right. This is falsy. But if I put the number 1 here, right, this is truthy. Right. The string of a number 0 is a non-empty string. So this is truthy. Right. And so everything will resolve to one value or the other. And there's only 6 things that are by definition falsy, which again are false, the actual number 0, empty strings, null, undefined, and not a number. Everything else is going to be true. Right. So we can go into test and we could say parse int L, right? So we know that that's going to turn into not a number. All right, so this is falsy because parse int, the string L turns into not a number is falsy, so we get this as falsy. Any questions on truthy or falsy?
So you said for the falsy ones, those 6 values will always return falsy in JavaScript, but anything else will return truthy, right?
Correct.
Okay. So the list that's on the slide for truthy is not the only list out there.
Correct. It's everything. So these are just like some like the gatyas, but it basically like a full array, everything other than these 6 values. Like these are the ones that are maybe not intuitive, but they will still return truthy. All right, and that is it for truthy and falsy. Next is recursion. Has anyone in the class had any exposure to recursion? And you don't need a ton of exposure, just you've heard of the concept. Okay, Frank, you're familiar with it. So I'm not gonna like call on someone and make them solve the first solution. I'm just curious if anyone's heard of it before or not. All right, so recursion is the process in which a function calls itself. That is, a function recurses. All right, using recursion to solve a problem requires 2 cases: a base case, the condition in which the function stops calling itself, and a recursive case, the case in which the function returns itself. All right. If you do not have a base case, or if you are not progressing towards your base case, you have an infinite loop, right? You will have infinite recursion, and by infinite, you are limited by the amount of memory that you have allocated to your computer or your replet. But it will keep recursing until you run out of memory, and then your program will crash. All right. And so if we look at this, where we have a function sum up to, and we have the base case, which is if the number is triple equal to 1, return 1. Else, the recursive case, right? And the recursive case is the case in which the function returns itself. So notice how we're returning here, and we're returning num plus supply or sum up to num minus 1. All right, and so let's just walk through this in the slide, then we'll do it in the replit. So if I call sum up to 5, the first time I call it, right, sum becomes 5. The base case is if sum, or in this case 5, is triply equal to 1, return 1. This is false, so we skip over this and we go to else. So we return 5 plus sum up to 5 minus 1, right? So this function call right here becomes this, sum up to called with the number 4 in it, right? We failed the base case again. We recurse a second time. So our call depth is 2, right? So this sum up to 4 minus 1 is sum up to 3, right? We check the base case. We fail the base case. We recurse a third time. Sum up to, so we're returning 3 plus sum up to 3 minus 1. That is sum up to 2. 2 is not equal to 1. We failed the base case. We recurse a fourth time. We return 2 plus sum up to 2 minus 1. So that function call, the fifth function call, is sum up to 1. That is true, right? We finally hit our base case. So we return 1, and this becomes return 2 plus 1. This becomes, and we return 3 out of here. So we return 3 plus 3, right? So we return 6 out of here, and we return 4 plus 6. So we return 10 out of here, right? And then we return 5 plus 10, which is 15. And then we're basically done. We're out of the call stack, right? So 5 plus 4 plus 3 plus 2 plus 1, right? So 5, 9, 12, 14, 15. All right, let's go ahead and take a look at this in our replit for the notes here. Let's go recursion. All right, we can say let add equal, or I guess we'll just call it sum. We're not going to be adding anything. Equals num. And we'll do console.log sum 5. All right, and so we need a base case, and that is if num triple equals 1, return num. Else we're going to return num plus sum num minus 1. All right, and so remember, the last thing a function ever does is return, right? But what happens with this is when we have a recursive call, we do not return immediately. We will keep recursing until we hit just a return, right? So we're opening up another function call here, and we'll keep doing so until we hit our base case. And then we're basically adding things to the memory stack. And so once we hit our base case, we will then start returning line by line all the way up back through the recursive stack, right? So I would expect that if I do this, I should get 15 again, right? And there's my 15. So let's go ahead and let's take a look at this over in Python too. Pop this out of the console for right now. All right, so this is going to solve this in 17 steps. All right, so I'm going to take my first step. We're going to load our function into memory. Second step, we're going to call our function. All right, so now we're at num is equal to 5. We're going to fail our base case here. Right, so we skip over it. So we're returning num plus another function call of sum of num minus 1. Right, so now we see that we've got num is 4, 3, 2, here's 1, right? So now we're going to hit this as true, right? So there we're going to return num, right? So the return value is 1, the return value is 3, the return value is 6, the return value is 10, and the return value is 15, and that is our final return, right? So basically when we do a recursive solution, we're replacing a loop and with a whole nother function call, a recursive function call, right? If I wanted to solve this iteratively, or what we would call functionally, I could do the same thing down here. So I could say let, we'll call it functional sum equal num, right? And then we could say for let I equal 1, I less than num, I plus plus, result equals 0, and then we'll say result plus equal I, and then we will return result. And let's go ahead and console.log. And I may have to be that less than or equal to num. We'll see here real quick when I run this. Well, in fact, I'm pretty sure that's what I'll need to do. Do that, and then we'll say functional sum 5. All right, so I got 15 and 15. And same thing, if I grab this now, pop this out of the console, visualize execution, right? So it's taking 5 more steps here to finish this, right? So we load our function into memory. We've got our num is equal to 5, result is undefined. Now it's equal to 0. And we're going to start looping here, right? So block, so we're into our loop, result plus equals I. So the result is equal to 1. Result is equal to 3. Result is equal to 6. Result is equal to 10. And result is equal to 15. Now we're at basically I is going to be equal to 6. So we are not going to go into the loop one more time. And we're going to pop down here, return our result, which is return value of 15. Right. And same thing here. If I were to bump this up, right? So I could say 10 and 10. Right, 55 and 55. And so you can see here, we're scaling this up. We get the exact same thing. This would be all right. Any questions on recursion? And don't worry, this won't be the last time you see recursion. Yeah, still trying to wrap your head around recursion. there is a lot to it. We'll do some of the problems here. Those I may lead the class through, at least like the first one, just to get like another look at how recursion works. And also kind of like the issues behind recursion. For small little problems like this, there isn't going to be much of a difference between doing this in a loop. But I know one of the problems on here, I think it's like the Fibonacci sequence for recursion is a bit of a mess, because each time you recurse through, you actually end up making two function calls. So on the first time through, you have one function, or at 0 calls, you have one function. Your first time through, you have two functions. If you have to go another layer deep, you have 4 functions. If you go another layer deep, you have 8 functions, so on and so forth. And if anyone's familiar with the famous rice on the chessboard problem, that's why recursion can be difficult to manage, right? So like if you're calling 2 additional functions each time in, and you start getting to 30, 40, 50 recursive calls, you can end up with thousands of functions in memory, and you can run yourself out of memory fairly quickly. A real world use case for recursion is going to be dependent upon the language that you use. I can't honestly give you a good real world use case for recursion in JavaScript. That doesn't mean that there isn't one out there, but I've never used recursion once in JavaScript. And because of the aforementioned memory issues, I wouldn't. Some languages like Clojure, which is Clojure is a functional language, which is a different type of language that you probably haven't had any exposure to yet, which is not a big deal. You will not learn anything about a language like this in Code Platoon, or really any boot camp that I'm aware of. But this actually has so there are no loops in Clojure. So I believe they should have, right. So they have a actual built-in function called recur that actually recurses through whatever you would do instead of a loop. And so like in a language like Clojure, which can be used to write backend servers, the language got really popular for a little while. A couple of famous software developers like Bob Martin championed Clojure, but it didn't it got really popular for a few years, and there's definitely software out there written in Clojure that's still in existence, but I don't know how many brand new projects are being started up in Clojure every day. But yeah, so depending on the language, there can be I'm not a data scientist by any means, but from what I understand, like data science may leverage recursion depending on the language that you're using. But outside of that, for everyone in this class, probably the most poignant real world example is that they may ask you to solve something in recursion in an entry level coding interview. Like they may give you something like basically like what we just did, where it's like, hey, loop together and add all the numbers in this, and if you solve it, great. Like, can you now solve this recursively? Right. And so it is always something that is a possibility out there in the wild. All right. So we finished at detention at 6:45, so we can jump into a challenge. Before I do that, any other questions that anyone wants to ask me about sessions 1 through right now? If you want to talk about anything you ran into, challenges outside of class, any concepts you've come across, any of the old challenges that you're still struggling with, any of the ones that we skipped over, feel free to throw it out there now. We've got a couple of minutes to talk about it, and then we'll move into a new challenge for the evening. If anyone's got anything for me. All right, that is a sufficient awkward pause. So we'll go ahead and move on to the challenge for the evening. Let's go ahead and jump into camel case. And let me drop the link for that in the chat. Oops. I don't want to fork it. Grab. Got those. All right. So there are a couple of variable naming conventions in programming. There are camel case and snake case. The JavaScript language subscribes to camel case. Camel case is a naming convention for a variable that contains multiple words. The entire first word in the variable's name is lowercase. Every subsequent word's first letter is capitalized. There are no spaces or underlines between the words. They are combined together. In this challenge, you will write a function that takes in a snake case argument and converts the sentence into a camel case convention. All right, and so let's go ahead and do the prep on this. So if we look at this, we're going to get one parameter, which is a string, represents the name in snake case, and we need to return one string, same as above, but in camel case. All right. And so example, we can say see below. All right. So taking a look at this, we've got my name is Kramer, first name, array of names. All right. So I have a string. I need to iterate through the words that make up the string separated by underscores, right? Um, all right. Does anyone have any questions for me on what I did in the prep work or the pseudocode? 1 second here. Let me pause recording. All right, everyone, welcome back from the camel case challenge. So it is 7:28 or 7:26 p.m. Monday, August 28th. We're going to go ahead and go over the solution as a group now. All right, so we already did the prep work and we did the pseudocode. The one thing I want to throw out here is, will I be able to do this mutating my string in place? And I said, nudge, nudge. You cannot. Remember, in JavaScript, strings are immutable. So that is kind of a tricky part of this problem. And I'll show you how we can work around the string being immutable. All right. We're going to do this one step at a time again. So we'll say console.log input. All right. And so I'm seeing my name is Kramer, first name, array of names. Just for right now, I'm going to comment these two out just so I've got less output on my screen while I'm doing this. All right. So I know that I need to get all of the words and get rid of all of the underscores. It sounds like most of the groups got to this point. How did somebody tackle this? What can I do? There's a built-in I can probably use for this, right?
Yeah, split.
Yep, dot split. And what should I split on?
These the underscores or spacing.
So not split, and I'm going to give it the string underscore, right? And so let's go ahead and see what that looks like. All right, so I've got my name is Kramer. Each one is a word, so I'm feeling pretty good about this. I think that's a good next step for me. All right, and now I've got an array. So let's go ahead and take this out of my console.log, and we'll say let array equal that. All right. And now I need to iterate through each thing in my array. And if I remember correctly, I believe that is a for of loop. If we go all the way back to day one over here, where are my iteration? Right? For an array. So I can say for word in array, right? And let's go ahead. Oops. That we'll move our console.log inside of our for loop, and we'll say word, and let's see what we get there. We get 0, 1, 2, 3. So do word. Nope, because I did in instead of. There we go. My name is Kramer. And actually, I'm not going to be able to do this way. And the reason being is because when I do a for of loop, I'm doing it for every single element in my array. And because I do not want to capitalize the first word in my array, I don't want to do the for of loop. So I'll actually do this as just a standard for loop. So we'll say let I equal 0, I less than array dot length, I plus plus. And we'll clean that up. And now we'll have to do array I. And if we run this, whoops, cancel that log array I for let I equal 0, I less than array dot length, I plus plus. All right, so there it is. And now, because I don't want to make any modifications to the first one, I can skip that 0 index because I don't need to make any changes there. We'll bump I to 1, so we'll start counting at the second index position, and I get name is Kramer, right? Because I want my to be all lowercase. I'm going to need to figure out how to uppercase the first letter of each of these. All right, so now I am here at array I. And so let's go ahead and take a look at something here. All right, so I can say, let's see. So we could say let first letter equal array I 0. And let's go ahead and console.log first letter. All right, so I get that. And because I cannot change it, so I cannot reassign just one letter in my string because strings are immutable, I can, however, save it to another variable. All right, so I could say uppercase, or I believe it's 2 uppercase. All right, so now they're all there. Now, JS, how do I get part of a string? The substring is a built-in function in JavaScript which returns the given string from the start index to the end index. Right, so I don't want you Edureka is my guess. So here's MDN substring, right? And so 1, 3, or I can just do this. So index start or index start, index end. So I only need an index start. And we could do something like this. So I could say, let rest of word equal array I dot substring, and we'll start counting at 1. And so let's do rest of word, and I've got 2 typos to fix. Now let's go fix the one back up here. All right, so there's name is Kramer. Right, so now I could do something like this. And now I've got all of these here, right? And so now I cannot mutate my array in place, but what I can do is reassign the value in there. So I can say something like array box I is now equal to this. All right, and so if I come down here and console.log my array, after I get done with my for loop, I get my name is Kramer. All right, and now I can do a dot join. We can do it on an empty string. And I get my name is Kramer. All right, and I'm still getting false because I'm not returning it yet. All right, so we can take this out of the console.log. We can return it. All right, and there's our true. We'll uncomment these. And I get true, true, and true. All right, now with this, I could take all of this, right? So I could just do array I, like array box I, box 0, 2 uppercase, plus array I dot substring 1, right? And just put this here and not assign it other variable names. But again, so I could have shorter code, less input here, but I feel by doing it this way, it's telling more of a story. So I know that this is giving me the first letter, and this is giving me the rest of the word, and then I'm basically adding the first letter to the rest of the word, right? So to me, this is a little bit more readable. All right, and so we got our split up here, our join down here, and that is how we get a solution to this one. Any questions on any of the steps that I took towards working on a solution for this one? All right, so I am going to, we'll add this one in. Let's go ahead and pick another challenge. All right, so we just did detention, camel case, presidential info is pretty easy. Let's take a look at high score. All right, so write a method that takes in an integer array of student test scores and returns only the highest score. All right, so we get, sorry, did somebody have a question? So we take in an array of integers, of numbers, so whole numbers here, and we have to find the highest score in here. All right, now with this, there is a built-in, right? So like if we look at array, and I think there's, actually, I don't know if there's a array that just returns the max value from here. Maybe there isn't. But if there is and you find a way to do it, don't use it. I would ask that you solve this using some form of iteration, be it a for of loop or just a standard for loop, and basically find a way to isolate the highest value in the array and then return that value. So let's go ahead and fork this, and I'll drop the link. It's that, we'll fork it. All of this. All right, so we're going to get one input, which is an array of test scores, or we'll just call array of scores. And we need to return one integer that represents high score from array. Example would be C below, right? All right, so I'm going to drop this one in here. And I am going to paste that. Let me go ahead and pause this. All right, everyone, welcome back from the high score challenge. It is 8 p.m. Central Time, Monday, August 28th. It looked like one group was able to solve it with a loop. I had another group say that they were able to solve it with some built-ins. So we'll go ahead and go over a couple of different solutions here. All right, so first off, we'll go ahead and build this out to solve this in a loop. And we're going to take it one step at a time. All right, so let's see here. So we've got student scores, and let's make sure that we can see our scores here. And we can, there's our array. All right. And so I need to iterate through each of my scores and see which one is the high score. All right, so what we can do here is we can say let high score equal 0. And now we will go ahead and write our for score of student scores. All right, and let's go ahead and console.log score and see what we get. All right, so that looks like all of my scores to me. So now what I could say is just like kind of what we did with the detention challenge is we need to check against high score to see if our score is higher than that, right? So we can say if score is greater than high score, high score is now equal to score. All right, I don't need an else on this. We could do a ternary and just reassign high score to itself, which would in effect not change the score, but because I don't actually need an else, I'd probably just write an if statement here. All right, and at the end of this, we can say console.log high score. Oops, reference error, high score is not defined. I've got a error here somewhere, so I'm going to for the if. Okay, where am I blowing my probably
Line 18.
Line
It's
18.
like it's not capital the S.
sorry, you're absolutely right. So, and I didn't look at my error message, and all right, score. And there we go. We've got 92 and 97. All right. And so that's how I do it in a loop. Justin, you had mentioned your group solved it with just some built-ins. What built-ins did you utilize?
We used sort and reverse.
Okay. So if we were just to do something like this, so let's go ahead, we'll comment this out, and we'll say solve with loop. Right. So we could say student scores. We'll just do console.log student scores. Let's go ahead and run it. And we get them out of order. Right. So we could then say dot sort. And we can run that. And we get them from lowest to highest. I think I can even do A minus B in here, if I remember correctly. No, I've got to do it as a callback function. So it's sort AB A minus B, I think. No, how about B minus A? There we go. So we can even skip the dot reverse. So we have not talked about dot sort as a built-in function, and I just jumped to some intermediate developer code there. So let's talk about this concept here real quick. So dot sort is a built-in method that takes a callback function. This is a callback function, right? And you don't have to give it one, but we do have the opportunity to. So let's go ahead and look at where it is sort. All right, so sort method of an array instance sorts the elements of an array in place and returns the reference to the same array now sorted. The default sort order is ascending, built upon converting the elements into strings and comparing their sequences of the UTF-16 code unit values. The time and space complexity of a sort cannot be guaranteed as it depends upon the implementation. All right, so, and we've got sort, but optionally we can give it a compare function, a function that defines the sort order. The return value should be a number whose sign indicates the relative order of the two elements. Negative if A is less than B, positive if A is greater than B, and 0 if they are equal. Not a number is treated as 0. The function is called with the following arguments. The first element for comparison will never be undefined. The second element will never be undefined. If omitted, and array elements are converted to strings and sorted according to each other's Unicode code point value. So we had looked at char code add at one of the previous evenings, and that's how we saw like capital A had like a value of 65, capital B had a value of 66. So they convert everything into those Unicode or AC values and then sort them based on those numeric values. What I did is basically because A is the first comparison, and by subtracting them, I just reverse the polarity of the sort function. All right, so there's my compare function or callback function. And I did a B minus A to basically reverse the polarity of it. So instead of getting the lowest value first, I got the highest value first. And now we could take box 0. Right, and there's my 92 and 97. And if I were to return this, right, I can now basically get the same things here. And these aren't console.log. These aren't in a console.log. So 1 second here. That triple equal and triple equal. All right, and I get true, true. And if I swap these, take this back out of the console, hit return. True, true. All right, so 2 different ways to solve this. One using built-ins and the other using the like an iterative method. Any question on either way that I solved these?
So just as a test, because I saw some weird stuff when I was looking this up. I injected the number 100 into one of the tests and tried to make the answer 100 as well. And the way that I solved it, it still came out to 92. I was wondering if both of the methods you just did would give you the 100.
So I still got a true, true for the iterative. Let's try it this way. We get a true, true.
Okay. That AB is the way to go.
Well, even with this, right? So if
versus sort and reverse.
Well, let's go ahead and take a look at that real quick, right? So we can comment this out and we'll say this, and we can go back to the default just sort here. So let's go ahead and I'm not going to return. I'm just going to console.log it for now. Console.log. Right. So yeah, it looks like it's giving me that 100 up in the front, just in the raw sort. Right. And so if we just reverse it, right, so we're still getting the 100 there at the back. So yeah, when we get the triple, or if we were to even do like 300, 496, so on, I'm not worried about the true false right now. I just want to see what happens here. Right. So we can see like we're getting this, and then the triple digits, because it's defaulting to that Unicode or UTF-16 format, something's probably getting totaled up differently, like a 3 and a 0 and a 0 are adding up to less than the Unicode values for a 9 and a 2. And that's why they're getting sorted that way. And so by doing it this way with the actual sort function built into it, right, so now we've got it there, right? And even without doing anything, like without reversing it, which is this is what I would do at this point, is reverse it and then just grab the 0. If you did it always in ascending order, you could always just grab the last index value as well instead of the 0 index value, but then you're doing the array length -1. So just a little bit more code there. All right, so Yeah. This would be a solution, or I guess I should say that this would be the solution that I would use for this one, and you could solve it either way. So good call out there to point out some of the oddities in the sort functionality. All right, we could even js.sort doesn't put numbers in order. All right, by default, sort uses alphabetic sorting instead of numeric. Not a lot of additional explanation how certain fingers correctly. Yeah, so instead shows this. By default, the sort method sorts elements alphabetically to sort numerically. Just add a new method which handles numeric sorts, sort number shown, right? So this is older, right? This is all the way from 2009. We're just building it into, this is doing the same thing. It's just a more syntax, and now we can write it like we don't need to put function in there, and we can use the fat arrow. But they're doing the same thing there. All right, so any other questions on this one? Okay, so let's go ahead and pull up another challenge here. So we just did high score, and let's go ahead and take a look at 2 strikes. I believe this will be a good one. Yep. All right. So write a method that takes in a string array of license plate numbers. The method should return a string array of any plate numbers that appeared at least twice. If none of the plate numbers appeared more than once, the method should return an empty array. All right, so this first example, 345 Bravo 317 appears twice. So we return an array that has it in here. All right, so like it's in the return array. So in this example, none of the license plates have duplicates, so we just return an empty array. So let me drop this into the chat. There we go, and we're going to fork it. This. All right, so we're going to get one param, which is an array of license plates. Right, so this can be an array of strings or numbers. Notice these first 2 examples are strings. This last one is an array of numbers. And we are going to return one item, which is an array with all of the plates that have duplicates. All right. In example, we can say C below. And for pseudocode, we are going to say All right, so let's see if this is small enough to fit. It is. So, and I'm going to give an extra test case here. So we'll go ahead and do this. And we're going to this. And this. And that should look like. All right, and I don't care which order the plates appear in. They don't need to be sorted or anything like that. It's just as long as you basically get something that has these two elements in it. And so let me copy and paste this over real quick. And I'll give everyone a second to copy and paste those in. Let me pause the recording. All right, 8:51 p.m. Central Time. We are back from the 2 strikes challenge. So let's go ahead and go over a possible solution to this here. All right. So we want to take it one step at a time. So we're going to take a look at our plates. All right. I'm going to, again, comment these other ones out just so we've got the one so we don't get confused. All right. So from here, I need to grab a plate out of here and compare it to the rest of the plates. Now, when I compare a plate to all the other plates, I then don't need to grab the next plate and compare it to this first one. So what I can actually do is remove the first one or the last one. It doesn't matter which way I go with it, right? So I could do something along the lines of pop, right? So if I console.log plates.pop, right, I'm taking the last one off the end of the array. And then also if I console.log plates here, right, notice how I've only got 4 in here now. All right, so I've actually removed one. So what we could do is we'll say let plate to check equal plates.pop. All right, and rid of that. And let's say for we'll say plate of plates. And we'll console.log plate. All right, and I'm only getting 4 plates here. All right, and so I need to also have something that holds my results. So I can say let results equal an empty array. And then I'm going to return my empty, or I'm going to return results, and I'll fix that spelling error. Right, and if nothing matches, I'm just going to return the empty array. Right, and so which is what it tells me to do. Right, so basically the method should return an empty array if there's no duplicates. And so now we can do some comparison logic here, right? So I can say if plate is triple equal to plate to check, right, we can do results dot push plate. Right, and so if we come down here, so there's our if statement, And there's that. So let's go ahead and console.log results. All right, so there's my one plate in there, right? So that would solve the first one. Now, and this is why I added that new one in there, is because if I do something like this, right, now I'm getting the plate in there multiple times, right? So I'm only getting the one plate. So this solves it for partial, but it doesn't solve it for all of them, right? Same thing if I do this and this. I don't need this console.log of results here because we're console.logging a function call, right? So I've got this one's correct, this one's wrong, this one's correct, and this one's wrong because we're getting multiple twos in here. All right, and now let me just check this real quick. So I had added 5A 22845. Right, and so what we're doing is we're only running through one time at this point. And so what we would need to do is actually probably move this down into here. Now let's see if this changes things, right? So now we've got both of them there. We've got a 2 and a 3. I don't necessarily want that 3. I don't know where that one's coming from. Right, and so let's go ahead and take a look here. So this is, it's 8:56. I don't know if we'll get quite to the answer before the end of class on this one, but if not, we'll lead off on Wednesday with it, and I'll still post this with the notes tonight. All right, so basically each time that I come in here, I am console.logging each of the plates. So I don't think I want that in there. And so we're going to pop the first plate off. And then for plate of plates, we are going to check each one of those against the plate to check. And so this one will actually require 2 loops to do as we loop through for the I less than plates dot length. Sorry, and I think I jumped into this one too quickly. I've lost my place in it already. So why don't we do this? It's 8:58, almost 8:59. So I'm not going to have the solution in the next minute. If we want to, as a class, we can hang out. If not, we can, and I would prefer to just basically start this off on Wednesday as soon as we get back to class, if that works for everyone.
That works for me.
Cool. So sorry, I shouldn't have tried to solve this one in 10 minutes with everyone. All right, so let me go ahead and we'll call class here then. And let's go